Decision analysis is the topic we are going to discuss in this class, and this is going to be your second last class. Next week we will be completing, and I'll give you a quiz on this chapter also for this week, and then you'll have another quiz for next chapter, and finally we'll have an assignment on both these chapters. All these quizzes and assignments are important for you because we don't have a course project in the course, so those grades for course projects are also to be gained from these assignments and quizzes. So you have to be careful while you are submitting your assignments and quizzes to score as much as possible. We are close to the finals. I think in the mid of April you will be taking your final exams. So I'll suggest that you start preparing for the course, because it is possible that you find the topics here slightly more difficult than other courses. So I suggest that you keep revising what we have done so far. The syllabus for the final exam I'll send you after 1 or 2 weeks. After I have finalized all the grades and everything, I'll decide on the syllabus and send you. So let's start with the new topic, which is decision analysis. Decision analysis is a concept that we have already studied in this course right from the day one. We studied that the most important role of a manager is to take decisions regarding the use of resources, mainly in operations research. Those resources may be time, money, those resources may be machines, materials. So it has to be decided how well the resources can be used. We learned about constraints, we learned about objectives. All those concepts are there in this topic also. But what we need to understand is that when a manager takes decisions, it is possible that there are many circumstances or conditions which are not in the control of the manager. So we need some tool, some methods, scientific method, as we have been telling right from the day one in this course, that operations research is a quantitative technique, quantitative tool to take decisions. So we need to have some tool, some method to take decisions which help us in having some solid reason why we chose a particular decision, given the condition that the external circumstances were uncertain. So let's look at this picture and understand what does it mean by the uncertain external circumstances. So this is a very simple example, not from any sort of business, but this example is from our general life, which represents the uncertainties in the external environment. This figure is popularly known as a decision tree. Okay, it almost represents a tool in decision analysis called decision tree. What we can see here is that let us assume that there is a student whose parents are who is planning to do something on the weekend. So today is the last day of the week, and then we will be having off on 2 days. So we all have some plans. So we do it right in the early part of the week. We plan what to do this weekend. So we are planning a weekend. Now you see the first on the top if you can see, the option is there is a possibility that the student's parents are coming to meet her, and when that is the possibility, now on Sunday her parents told her that we are going to come to meet you. So she said, okay, I have two options. This weekend, if my parents are coming, so you see on the left side, there is an arrow here, and it says, when my parents are coming, if they come, then we will go and have some can you see the screen? Okay, so when the parents will come, so she is making a decision tree. On one side, she says, okay, if they come, we will go to watch a movie, we'll go to cinema, and there is also possibility that they may not come, they are coming from some other place. So they may get stuck. They say, okay, we are not visiting this week. We may come next week. So then she has to also take care of that possibility, because if she doesn't plan in advance, then she will be having no idea. She'll feel sad. She didn't plan anything. So she is planning right now for the next week. So if they are not coming, then she has three options. She can play tennis, or she can play some outdoor game. She can also go for shopping, or again, she can also watch movie alone, or she can stay in. With parents, she has just one option. She has decided that if they come, we are going to watch cinema. But if they don't come, then she has many options, four options. Now she is considering on what to do. So these options are dependent upon an uncertain condition, which is weather. And as we all know, that the weather is not in our control. So if the weather is not in our control, what to do? We don't know how will the weather be. Even we don't know how the weather will be tomorrow. So we have to take into account all the possibilities, all the chances. One chance is that the weather remains sunny. The other is that the weather gets windy. The third is the weather becomes rainy. When the weather is sunny, if it is like today, how it is, I hope it is the same in your place also. In Azizia, it's very sunny. So we can decide, the student can decide to go for some outdoor games. But if it is windy, lot of wind, then it's not possible to play anything. But still, some outdoor activity can be done. So there are two options: either go to a mall and do some shopping, or go for cinema. On what basis? Another condition which is not controllable, and that is money. Money, if lot of money, she has got lot of money, then shopping will give her more recreation. She will be able to enjoy more. But if there is not much money for shopping, then the option left is to go and watch cinema. It is less costly. And the last option is, in case it rains, then what to do? If it rains, then there is no other option but to stay in, have and relax at the house itself. So this is a diagram which is called decision tree. Okay, not exactly decision tree, but it is almost a decision tree. Decision tree has some more shapes which are missing here, but it is a rough decision tree which helps us. Now this picture when we have made on Sunday, and on Friday morning when we get up, we have this picture. Now we will face the reality on Friday. So when Friday morning we get up, we see this picture. Now the parents are coming or not coming. So they called you, they say, oh, we are not coming. Now this chart you will see, and then you can decide, what am I going to do today? So this picture is a plan. This picture is a plan for next days, for future. And the most important feature, most important characteristic of this plan is that it takes into account all the maximum possibilities possible, which was not the case with linear programming or transportation. Those were deterministic models, and those models did not take care of or were not affected by any external conditions. We were told that, see, this is my resource, these are the constraints, this is my objective. Now tell me how much to produce, or tell me how can I, what may be the minimum cost. But here in this case, we have to take into account some scenarios also, some different conditions. So that makes it different than the tools that we have already learned. So in more particular, when we can think of a business problem, this will explain a problem from the business where external circumstances are not within the control. And what I will suggest is, if some of you can make a picture like this by reading this, then you will be able to understand well. Now what happens is, this is an example from a business. There is a distribution company and they are planning to purchase a computer. There is a proposal to purchase a computer. Now, as you know, in businesses, every money, every real, that we spend has to be accounted for. We must take care of the money. So even if it is your own money, even if you are running your own business and the money is yours, but when we work in an organization, we must be accountable for each and every halala that we spend on business. So what happens is, there is a proposal to buy a computer. In general life, in a computer may be nothing. You can just go and buy a computer. But when it comes to business, there is a question, if I buy a computer, I spend money on buying computer, will it give me the proper return or not? Or it will increase my cost, because when you increase the cost, the profit may go down, or even you can make loss, because it's cost minus sales that gives you the profit. Now you spend 10,000 reals on computer and your sales is only 9,000. You have started making profit. Earlier you didn't have a computer, you just have a labor who used to write all the orders, and you were paying just 2000 reals and your cost was just 8000. So with 9000 you had a profit of 1000. After buying computer your profit became loss. So that's something the company or the manager has to think on. But the fact is, a decision has to be taken in a proper way, in a scientific manner, so that there is no regret, there is no loss of opportunity. So there is a proposal for this company to buy a computer. Why? Because they feel that if we buy computer, the processing will get faster. Order processing will get faster. So if the order processing gets faster, what will happen? The profit will go up. The company will make more profits and it will be good for the company. So that is a good part. But how will the order go up? The order will go up. What does it mean? It means more customers. More customers buying the products or making orders. If more customers are there, what are these various factors which affect the customer order or which affects the demand? One of the most important factors is the economic condition. So if the economic condition is good, more customers will come. They will come and buy the products or order. But on the other hand, there is a possibility that after this company buys a computer, the economic condition gets bad. Then what will happen? The order numbers will go down. Or even if it remains the same, the increased cost will result in losses. So the manager will have to take into account the two scenarios, the two conditions which are not in his control, which are not in the control of the manager. The manager is helpless. And we know that there have been times where we felt that something will work well, but in reality what happened? It turned out to be bad time and you lost money. So this is a typical example to show the decision analysis. Now we are not taking decision, but we are just trying to formulate the problem in decision analysis. So what happens if you can formulate the problem in same way like this one, then I hope I'll be happy to know that you have started understanding what this picture looks like. This is actually the formulation of this problem, this type of a problem. Okay, so let's move forward. In the decision analysis, there is a condition or there are some external factors which are beyond the control of the manager, but we have to take care of the decision. We have to make a decision. Without making a decision, we cannot move forward. We have to decide, okay, to buy a computer or not to buy a computer. You have to take a decision. And it has to be a good methodical scientific decision so that tomorrow there is no regret and you increase the business also and don't lose money also. So those conditions, now this is very important for you. You have to remember the example, the good and bad times, good and bad economic condition. Also remember now the first point, which is the term called states of nature. Okay, so this you should remember this. This is something. This is the first point that you will remember from the chapter on decision analysis. Should memorize it. States of nature are the events that may occur, okay, that may perhaps, not sure, there is a possibility that it may rain tomorrow, and it is possible that it may remain sunny tomorrow. We are not, we do not have any idea. Those events, those probabilities are called states of nature. So you ask yourself, did you understand the states of nature in this problem? The states of nature, good economic condition and bad economic condition. This was not the case with linear programming or transportation that we learned earlier. There were simple resources, constraints, objectives. States of nature were not taken into taken into account while we were solving those problems. There was possibility that we would have said, okay, we will produce bowls and mugs. These are the resources, but these are two conditions. In good economic condition, this will be the profit. In bad economic condition, this will be the profit. Then in that case, it was we could not have used the same graphical method to solve the problem. We should have used another method, and then there was a need for something like decision analysis and a stochastic model to solve such problem. Okay, so decision analysis, I hope you are now getting the idea of what decision analysis is going to help us in, and what does it basically deal in. So what does it deal in? It deals in uncertainty. It deals in the states of nature. Fine. Now let's come to solving or the methods of decision making, the scientific method of decision making for which we are actually learning this chapter, so that we can use those methods in our real practical and professional life. This chapter is mostly from your book, so you will take time out of your schedule and read the chapter. Try to read as much as possible from the chapter. This problem also is from the book, so it is better, along with the video that I am recording right now, it's better that you will go through the chapter. It will give you a better understanding. So let's come to, so we had first the example of a general program of a person, of a student. So she made a decision tree for the program. The second, we saw an example of a company deciding to buy a computer. I hope many of you would have made a tree like the first one for the second problem. Very easy if you would have done that. Now we are going to solve a practical problem. So this person who is on the screen is a manager, is an investor. An investor or a manager who, as you know, in companies they also invest. So when they produce something, after the year, when the year is over, they calculate that we have made a profit of this much. From this profit, the company decides what to do from this profit. So some profit, after paying everything, whatever the net income is left, net profit is left, the company decides, okay, now let us invest this money so that we can get more returns in future. Individuals also, if I am an individual, I have a lot of money, then individual investors also can invest money to increase the returns. So this lady, she has money and she wants to invest the money in real estate to increase the value of money in future. So what she is considering three options. Number one option, if you look at the left, you see she has one option of making an apartment. The second option is to build an office, and the third option she has is to build a warehouse. Now all of them are commercial items, they can be sold, and all of them will take time to be constructed. So the question before her, that is you can see there is a question mark. She doesn't know, she is feeling very confused what to do, what option should I choose. So here, she comes to you for help, and now you will try to use your concepts that you learned to help her take a decision, or maybe it is you who is standing there. So you are now having choices, and now you are trying to use the concepts you learn to solve the problem and take a good decision. So we come to the next important part of this chapter, which are the two main types of tools in decision making, decision analysis. We can divide the tools, classify the tools of decision making into decision making tools without probabilities and decision making tools with probabilities. Okay, so without probabilities and with probabilities. What does it mean, without probabilities and with probabilities? That is something you have to understand before we start understanding the various tools which are available in both of them. Probability means to calculate the chance of something happening. Probability, what does it mean? It means to calculate mathematically the chance of something happening. So when I use mathematics to make an estimate whether it will rain tomorrow or not, anything wrong there, that side? Can you hear me? When we calculate the chance whether it will rain tomorrow or not mathematically, that is called probability, and there is a full discipline called probability theory and probabilities in mathematics. So when we calculate probability or chance using mathematical tool, it is called probability. On the other hand, if there are states of nature, by now I think now we are moving ahead. I hope states of nature, the term you understand by now. So when we say the states of nature, we don't have any mathematical probability. We just say, okay, I feel tomorrow it may rain, I feel the parents may come. Then that is not mathematical probability. There is a chance. It's a chance, it's a possibility that there may be rain tomorrow or not, but we are not using any mathematical tool to guess, to make an estimate that there is 30% chance that it will rain tomorrow and 70% chance that it will not rain tomorrow. It may not rain tomorrow. So if we do not use mathematics to calculate chance, it is called without probability. I am making it as simple as possible to understand. When we calculate the chance without using mathematics, then it is not a mathematical probability. It is only a guess. But when we use mathematics to calculate the chance, we toss a coin in air and it comes down. A coin only has two sides. We can easily predict, or we can easily calculate the probability of getting heads or tails. It is 50% and 50%. But suppose we toss the coin in the air and the second time it's again head, so 2 by 2. Now what will happen? The probability of getting heads will start reducing or increasing with the number of events. So that is a mathematical discipline. We are not going to deal in that. You may have learned in business maths some of the basic theories of probability, because it is used in business a lot, especially in finance, in OR, we use probabilities. So there are two methods of decision making which may be classified broadly into decision making without probabilities and decision making with probabilities. The common in both are that there are states of nature. Now when we say decision making with states of nature, and now we are going to solve problem, let's come back to the problem that lady is facing. She is deciding on three options to invest her money, or she is the manager of a company and she wants to invest the money of the manager, apartment building, office building or warehouse. So we have learned in OR earlier also that there are some values which we get, which we are able to get from the market. We don't have to calculate those values. So for each option that she has, she makes some gathers information on how much profit can she make if she sells apartment, how much profit will she make if she sells office or warehouse. But she has collected the values which we call parameters in linear programming, in general OR model. We said objective function subject to constraints, and objective function you had parameters and variables. So here it is the parameter, the profits, and these values have been collected for two states of nature. She has got the information that if the economic condition remains good, she can earn $50,000 profit by selling apartment. But if the economic condition is not good, when her apartment is ready, she can make a profit of $30,000. So then for office building obviously, office building will give you more money, so she will make more profit. She can make $100,000 by selling office building, and if the economic condition is not good, what will happen? The people are not running business, they don't need office. In that case, it is possible she can make a loss of $40,000, loss minus. Now the third option, warehouse. Warehouse is not so good option, but still she is considering, because she doesn't want to take chance, she wants to consider all options. A warehouse will give a profit of 30,000, and if the economic condition is not good, then she will get $10,000 of profit. This table, is called a payoff table. When we got all the values and we write down the options of decision and the states of nature, and we fill all the values that we have got from we have not produced ourselves. We have got it from somewhere, some secondary source. This type of a table in decision analysis is called a payoff table. Payoff table. We have seen this type of a table in linear programming, in transportation. It's no different. We have just plotted all the values in a table. It is called payoff table, and this payoff table illustrates all possible profits or losses in the different decision making under uncertainty, or you can also write under the different states of nature. Okay, now another important point for quiz and your exam is the values, the parameters in this table are called payoff. So 50,000, 100,000, 30, all of these are payoffs, and that is why it has got the name payoff table. Let's move forward. Now we are going to come to the almost the main part of this chapter, that is to solve the problem and learn the various methods of taking decision. So you pay attention please, because now we are coming to the main part, and most of your quiz questions or the exam questions will be from this part. And if there is any question for you, please stop me by sending a message. I will take the question then, or I will answer at the end of the class. Okay, so how many methods are there in decision making methods without probability? There are 5 methods. We must know the names of all the methods that we are learning. So you will have to memorize the methods, the names of the methods in both the types, without probability and with probability. So when we come to without probability, the options are, the tools that we have are called the Maximax Criterion, the Maximin Criterion, the Minimax Criterion, the Hurwicz Criterion, and the Equal Likelihood Criterion. These are the 5 tools or methods we have got in decision making without, or decision analysis without probability. When we do not have any mathematical probability, we call it without probability, and we have 5 methods. Now let's quickly see. All of them are absolutely easy, simple. Just the names have made them look like something very complex, but they are very easy. But we have to learn those methods. The first method, whose name is the Maximax Criterion. Here you see how do we decide. This decision tool takes into account only the good state of nature. So in the payoff table, even if the poor or the bad economic condition is given, even if there are 2 states of nature, this method helps us, or this method includes only the positive side of the state. And when you consider only one side of the nature of the event, then what happens? We have to only consider apartment building, office building, and warehouse, how much profit we can make in the good economic condition. So which one gives us the maximum value? The maximum value is got in the office building, because that's the maximum, $100,000. No other investment will give us in the good economic condition. So as per the Maximax Criterion, this is the choice, this is the decision. Now let's look at the second option, second tool, which is the Maximin Criterion. In the case of Maximin, it's the opposite of Maximax. In the case of Maximin, what we do, we don't consider the good economic condition. We don't consider that, we only consider the poor economic condition. So what happens in the poor economic condition, which one gives the maximum profit? Apartment building. Why do we consider, or why this method considers the poor side? Because this is a method and it says that we should go for the safest investment. So safest investment means even if the economy is not good, what maximum profit we can make. So in that case, the maximum payoff is $30,000, and this criterion or this method is called Maximin. The next one is called the Minimax regret criterion. Now listen carefully so that you understand, because it is slightly more complicated than the previous two. Here there is a step to follow. You can see on the slide that in the good economic condition, all the values have been subtracted from 100,000. In the poor economic condition, all the values have been subtracted from 30,000. Question is why? The reason is, okay, listen carefully, very important, because this is the main step to learn. If you understood this, then it's simple. The reason is that in this method, we calculate how much money or how much opportunity we will lose if we do not go for a particular decision. So suppose, and how do we calculate that? We select the option that gives us the maximum value, maximum profit, and that becomes our benchmark, and we minus the actual values from the highest. So in the case of apartment, office and warehouse, if the economic condition is good, here $100,000 is the maximum profit. So now what we do, we subtract the profit that we get from apartment from the highest value in the options. So here we get 50,000, it is 0, and then finally it is $70,000. When the economic condition is poor, again we follow the same step. In the case of apartment building, we get the maximum profit, which is 30,000. So we will minus this highest, we will subtract the actual value from the highest. So 30,000 minus. Now here you see, it may, some of you may have understood, but just to make it clear, $30,000 minus, and this is a loss already. Loss is written as minus, and you know that minus multiplied by minus becomes plus. Alright? So minus into minus becomes plus. So 30,000 minus 40,000 becomes plus, and so it becomes $70,000. And finally 30,000 minus 10,000 is $20,000. So now we have 6 values: 50,000, 0, 0, 70,000, 70,000, 20,000. We have to find, and these values are not the profits. These values are actually the losses, and not exactly losses, but regret, the feeling of sad. So if I didn't go for apartment and I decided to build, if I didn't go for office and I decided to build an apartment, in case the economic condition becomes good and we still went for the apartment, what happens? We will be sorry we will feel sad that we didn't build apartment. Why? Because if we would have built apartment, we could have got 50,000 more. So this is the sadness, the regret, and that is why this table, when you convert into the opportunity cost or the regret, this is called the regret value, regret table. This is called the regret table. So now let's look at these values. Apartment building 50,000 0, office building 0 70,000, warehouse 70,000 20,000. Now how should we select which option is the best to go for? Here the rule is to select for the values which are the minimum. Select the value which is the minimum. Okay. Now in order to make it more simple, what you can do, you can just add these. Means it is not given in the book, but to make it more simple and less confusing, add them. 50,000 plus 0, 0 plus 70, 70 plus 20. This is 90, this is 70, this is 50. Which is the minimum? The minimum is this option. When you build apartment, whether the condition of economy is good or poor, this will give you the minimum sadness. That okay, no problem, I lost only 50,000. But if I go for office or warehouse, I will be the saddest. I can lose at the maximum 70, which is more than this. So in this method, we calculate the regret value. Then comes a method in which we just feel, or give some value to the level of optimism or the level of pessimism we have. It is not probability. This is not. Oh yeah, there is a good question, and that is why I knew, and this was a question in the earlier groups also. Who has written the question? Give me the name. This question is good. Gaida, okay. Gaida Subhi. Good economic condition and poor economic condition. Yeah, obviously, we see that 0 is the minimum in office and apartment. But that's why I said, see, in order to make it easy, what you do, add them both. So first convert the regret value into the payoff table and convert into regret table. Add both the numbers, because these are not the profits or losses, these are the sadness or regret. So what you do, add them. So add 50,000 plus 0, add 0 plus 70,000, add warehouse 70,000 plus 20,000. Now let's look at the values. We will get 50,000, 70,000 and 90,000. So taking into account both good and bad economic condition, which one gives us the minimum regret? It is apartment building, because 50,000 is less than 70 and 90. Okay, so in a way what the method is given in the book is to look at both the values. So what I feel the best option is to add them. That will help you solve the problem and understand better. Okay? Did you get me? What you do? Add both the values. Well, first make the regret table and then add both the values. Then see which is the minimum value. So don't make any mistake. In these ones we were looking for maximum values, but in the minimax regret value you have to look for the minimum value. That will be your answer. Now let's come to this one. This is also slightly tricky, just slightly, not too much. So in the Hurwicz Criterion, for each decision alternative, like apartment building, office or warehouse, it asks you, or in order to make it more scientific, or a better decision, the OR specialist tells you or asks a question that there are two states of nature, good and bad. We don't know how will it be tomorrow, and we are not calculating it mathematically also. But still, they tell you, okay, tell us how optimistic, or if I tell you, out of 10, how much do you feel are the chances that the economic condition will be good or bad? Any one. So out of 10, okay, suppose you say, okay, let's forget this. I ask you, some of you can just answer on the group, only one, not more than one. How many, what do you feel, what are the chances that you will get A plus in this course? Can you, anyone out of 10? It is not mathematical guess, it is just a normal guess. Tell me, how much do you feel, how confident you are? If I give you a scale of 10, you are confident that I will get A plus. So can you give me, how out of 10, how confident are you? 9, 10 out of 10, 0, 1. Give me a value. Ah, mashallah. So Ghaida says he will get 10 out of 10. So let's put the value here. 10 out of 10 means 100 out of 100. Or in case of probability, is there anyone more? Sadia is only 6 out of 10. That's good. You should be realistic. But I'm not saying 10 out of 10 you should not expect. Yes, 100% chance that I will get 10. I'll get A plus. It's okay. Very nice. But that's what we have to understand. That in this method, as you have rightly just answered, one of you said 10 out of 10, the other said 6 out of 10. But is it a mathematical method you used to give 6 out of 10 or 10 out of 10? No. You have not used any mathematics, you just used your judgment, your feeling. You felt you will get. So this is not mathematics, this is just guess. But still, this method is useful. So in the decision analysis tool without probability, let's say we are taking the value of Ghaida, 10 out of 10. So in probability, what we do, her value of 10 out of 10 is means that she has given 1, her alpha is 1, meaning she feels that she is she'll get A plus, and there is no possibility that she will get B or B plus or C. So what does it mean? 1 is the value for alpha, and the opposite, yani how, whether she will get less than A plus, no possibility, 0. So in this case it will be 1 or 0. There is no other possibility. There is no other possibility at all. 1 and 1 minus 1 is 0. So when we take the value of Sadia, she says 6 out of 10. So the alpha will become, how confident is she? Her alpha is 0.6. So when we say probability, it is normally calculated in the scale of 1, 0 to 1. But there is no such rule like that. You can also use percent out of 100 and multiply, no issues. If you use 100 also, no problem. But the only thing is you have to remember is, if one is 60, the other will be 100 minus 60, 40. If one is 6, the other is 10 minus 6, 4. The values that you will get, so first we calculated, asked you how much you feel. So this investor, in the book, the example that is given, the investor feels, okay, I am slightly pessimistic. Pessimistic, you understand, meaning I am not so confident that the economic condition will be good. So I'll give 4 out of 10 or zero point 0.4 out of 1 or 4 out of 100. So 40 out of 100. So how much is the value of alpha? 0.4. So when 0.4 is the value of alpha, 1 minus alpha will become 0.6. Now what to do? This method says just multiply those values with their payoffs and add, as simple as that. So multiply 50,000 by 0.4, 100,000 with 0.4, 30,000 with 0.4, and 0.6 you multiply by the second state of nature and then add them. So after adding them, you can see the values are 38,000, 16,000, 18,000. So which one we should choose? We should choose the maximum payoff, which is apartment building. So the method here is, now the question is, you will ask me in the exam what will happen, how will we guess? No, in exam normally I will give you, or any examiner will give you the number. In the case of this also, or they will just tell you, you think how much and solve the problem. So that is how we solve this problem. We just make a guess of the possibility, how the state of nature will be, and then multiply with the payoffs, select the maximum. That's the Hurwicz criterion. Exactly similar criterion or method is the equal likelihood criterion. Another name for this criterion is the LaPlace criterion. What we do here, in the case of Hurwicz, we made some guess of feeling whether what happens. We made a guess of the feeling, but here we don't make any guess. We divide the possibility of good or bad economic condition into 50-50. So we have now, in most of the classes, we felt, okay, let's make it a new name, let's give a new name to this method. We will call it Nus method. So that will make it more easy to remember, Nus method. We don't have to do anything. All the payoffs multiply by 0.5 or 50. That's it. So when you multiply 50,000 by 0.5, 30,000 by 0.5, and then calculate all of them. Now here I'll just try to make it clear. It is minus. Why? Because this is loss. So if the economic condition is not good, so that's why we are subtracting. Now the final values are here, 40, 30, 20. Again in this method also, which one we select? The maximum. Only in the case of Minimax regret, we selected the minimum, but in all others, we will select the maximum. So this completes all the 5 tools in decision analysis without probability. Now let's come to the final conclusion on without probability. So when we used all the methods, we saw that in almost all the methods except Maximax method, apartment building is the best choice. When we are not using any probability, mathematical probability, apartment building looks to be the best choice, and that is why this type or this decision who appears regularly in many methods, this is called a dominant decision. Okay. Now the question comes, the second type, the decision making with probability. Decision making with probability, I don't need to explain again probability. Now whatever you need to learn more, either you ask me later or search on your own, you will understand. Otherwise you will get confused. It is mathematical probability. So here the expected value method and expected opportunity loss method, 2 methods are there. So whenever in the question you will see something, so what we will do, today we are not going to solve the 2 problems. That we will do in the next class, and that will be the last class with solution on this problem and the new chapter, small chapter. So the two methods of decision making tools with probability are expected value and expected opportunity loss, EV and EOL. These are also, once you have studied and understood the decision making without probability, these two are almost same like the two methods, minimax regret value and the likelihood and Hurwicz method. So in the case of expected value, it's the same as LaPlace or Hurwicz, but the only difference here, the values 0.6 and 0.4 are not guess. That's something, please remember this forever. These numbers, which was there in the here 0.6 and 0.4, here 0.5, 0.5, these were guesses, but this number is not guess. This is a mathematical probability. It has been told to you, it is written in the question, or you calculate yourself, whatever, but this has been calculated scientifically. So it's given that the probability of good economic condition is 0.6 and the probability of poor economic condition is 0.4. Now this is given to you in the question. Rest of the things are exactly the same as we did in the likelihood or Hurwicz. So what we do, we multiply all the values with 0.6, all the values with 0.4 and calculate the total, select the maximum. So you see here the choice changed. Now in this case the choice becomes office. Why? Because of the probability. Because the probability of good economic condition is more, and that is the reason why the choice for office increases. So we will go for office in this method. Then the last method, expected opportunity loss, what we do? We do exactly the same as we did in the case of minimax regret. We convert this table into regret. It's the same regret table that we calculated there, isn't it? It's the same as we did here, this one. So this table, the only difference is we got the probability from mathematical tool. This probability is given to us. We just have to multiply these probabilities with the regrets and sum it. Here what we have to do, we have to calculate not the maximum but the minimum, because this is the regret. We want to be the minimum sorry. After 2 years, when the building is ready, we want to be the minimum sorry. So the minimum sorry is this 28,000, and again the result is that we select the office. Now last thing to discuss for the day is decision tree. As we saw in the first slide, decision tree is the representation of the various alternatives in decision analysis. It consists of some shapes. These shapes are squares, circles, branches. They all represent some aspect of the decision analysis or the problem. A square gives us decision nodes, circle tells us about the probability, and branches tells us about the decision alternatives. Why is it important? Because it is good to have picture of the process. With picture it is easier to make or solve problems. There are 4 parts of decision tree. There are alternatives, there are events, outcomes and decisions. Now the last point is for this chapter, for today, before we solve the problem, is how to convert. We saw the first example of the decision tree. Now this is a proper decision tree, and I hope everybody guessed right that this picture is the conversion of the problem that we just solved, the decision making with probability. We see here that the squares are the decisions, whether to purchase or whether to invest in apartment, in office, in warehouse. Now from there are, again, for apartment there are two options: if the condition is good, if the condition is poor. For the office there are two possibilities: if the condition is good, if the condition is poor. So this way we are solving the problem, and when we do all the calculations, we see which one is the best option. The office building is the best option to buy by applying equal the expected value method. We found the value of 44,000 for office building, and that is the option we're going to choose using decision tree. So decision tree is making us clear which option is the best. It's not rocket science, it is just the conversion of the problem into a figure, into a picture. And that's a very important tool in both business as well as in general life to make decision tree and take decisions. We will stop here. We will not go for the problems which are there. We'll solve it next week because it's very simple. We'll just take, because I want you to take the quiz first and try to look into the problems, because it's easy to solve, very easy to solve. Try to solve it, and when you come in the next class, I will expect that you will solve the problem before me. I will stop here for this chapter. The video is ready. I will upload it on YouTube, and then